Today we will discuss haloform reaction. First, you have to learn which type of compound undergo haloform reaction. Now, carbonyl compound containing ketomethyl group. Now, what is ketomethyl group? You see that CH3CO, that is called ketomethyl group. So, that carbonyl compound containing ketomethyl group and alcohol containing CH3CHOH, this group, they undergo haloform reaction. Now, acetaldehyde, it contains ketomethyl group. CH3CO, it contains ketomethyl group, so it will undergo haloform reaction. Now, in haloform reaction, see halogen and strong alkali, that X2 and that NaOH, because when we use chlorine we will get chloroform, when we will use iodine we will get iodoform, for bromine bromoform. So that's why we write X2, that represent that halogen. So what will be the product? Now CHX3, that is haloform. So carbonyl compound containing ketomethyl group in presence of halogen and strong alkali, it produce haloform. Now for example, we will learn that preparation of iodoform. We can prepare iodoform from ethanol as well as that acetone. Mechanism of iodoform reaction. In first step, what happened? NaOH and I2, these two reacts to form NaOI. That NaOI, that sodium hypoiodide, that act as a mild oxidizing agent. It oxidize ethanol to acetaldehyde. So if we want to prepare iodoform from ethanol, in this case first step, see ethanol will oxidize to acetaldehyde in presence of that NaOI. Next, what happened? Now iodination takes place. All the three hydrogen of that methyl group replaced by iodine. Iodination step. So Ci3COH. Next, hydrolysis. Next step, hydrolysis. See what happened. And last step, proton exchange. That Ci3 minus, it will take proton from that formic acid. So you will get CHI3, that is iodoform, yellow crystalline solid, plus sodium formate. Byproduct is sodium formate. So if we take ethanol, iodine and NaOH, the final product is iodoform and sodium formate. Now that iodoform, remember, it has a characteristic smell and yellow crystalline solid. We can also prepare iodoform from that acetone. In that case, we will get iodoform and that sodium acetate. Acetone plus I2 in presence of NaOH. So what will be the product? Now see, CHI3 plus sodium acetate. Same step, first iodination, then hydrolysis, last step proton exchange. Similar type of reaction. Last one, proton exchange. Sodium acetate plus CHI3 iodoform. So from acetone we can also prepare iodoform. Now nowadays we not use that chloroform as an anesthetic agent. Why? Now if we keep that chloroform in normal that transparent glass bottle, what happened? In presence of sunlight, chloroform undergo oxidation and it produce highly poisonous that phosgene COCl2. So that chloroform it become toxic. That's why nowadays we not use chloroform as an anesthetic agent. What happens? See, now chloroform in presence of that oxygen and sunlight it form that COCl2 plus HCl phosgene, highly poisonous, phosgene. Now how we can remove that phosgene from that chloroform sample? Now if we add small amount of ethanol, if we that set that sample which contain that phosgene with that ethanol, see this reaction takes place. COs ethanol, 2 molecule of ethanol. What happened? Diethyl carbonate. In that way we can remove that phosgene, that highly poisonous phosgene from chloroform sample. Next, preparation of DDT. For this we need chloral, CCl3CHO, chloral, and 2 molecule of chlorobenzene. 2 molecule of chlorobenzene in presence of concentrated H2SO4. What happens here? That water molecule will remove and see we will get that DDT. See, that one is DDT. Dichloro, diphenyl, trichloro, 2 carbon, that's why ethane. Dichloro, diphenyl, trichloro, ethane. Structure is very important, that DDT structure.